In this session, I'll be explaining Y parameters. Short circuit admittance parameter or Y parameter. Earlier we have learned open circuit impedance parameter or Z parameter. You know why Z parameter is also called open circuit impedance parameter. Now we are going to learn short circuit admittance parameter or Y parameter. Y parameter is expressed as the two-port currents I1 and I2 in terms of two-port voltages V1 and V2 for a two-port network. Okay, so impedance parameter was like for a two-port network, the V1 and V2 were expressed in terms of I1 and I2. Here, in case of admittance parameter of a two-port network, I1 and I2 of a two-port network are expressed as a function of V1 and V2. So we can write the equations as I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. In the matrix form we can write I1 I2 Y11 Y12 Y21 Y22 matrix into V1 V2 matrix. In common we can write matrix of current is equal to the Y parameter matrix into voltage matrix. Now let's see how we can find the individual Y parameters Y11, Y12, Y21 and Y22 individually. In order to find Y11, Y12, Y21 and Y22 individually, we have to make each of these terms 0. V2 is equal to 0, then we can get Y11 and Y21. And when V1 is equal to 0, we can find Y12 and Y22 as we did it in Z parameter. That means Y2 is 0 when the output is short circuited. Okay, we'll see it in detail as two cases. So before that, I'll just explain. V2 is 0 when the output port is short circuited. Okay, and V1 becomes 0 when input port is short circuited. That is why the parameters are called short circuit admittance parameter. Earlier we had V1, V2 as a function of I1 and I2. Okay, that is Z parameter. So for I1 to be 0, the input port should be open circuited, and for I2 to be 0, the output port should be open circuited. That is why the Z parameter was called open circuit impedance parameter. Here, in order to make these terms 0, the ports should be short circuited. Okay, when a port is short circuited, the voltage across it is 0. That is, there is no voltage difference between these two points. Therefore, the voltage is 0. Therefore, that is why it is called short circuit admittance parameters. So come, let's see how we can find each of these parameters by short circuiting the input and output ports. Case 1, when output port is short circuited, that is V2 is equal to 0. Let's write these equations once more. These are the two equations for Y parameter I1 and I2 in terms of as a function of V1 and V2. So when output port is short circuited, that is V2 is equal to 0. From this we will get Y11 is equal to I1 by V1 at V2 is equal to 0. And also Y21 is equal to I2 by V1 at V2 is equal to 0. Now we have to write the name of these two parameters. Y11 is called driving point admittance with output port short circuited or short circuit impedance input admittance. And Y21 is transfer admittance with output port short circuited or short circuit forward transfer admittance. Okay, so by now you will be able to write Y12 and Y22. Try it yourself. I'll write it. Pause and try to write it yourself and see if it is correct. Case 2, when input port is short circuited or V1 is equal to 0. When V1 is equal to 0, we can find Y12 and Y22. Y12 is equal to I1 divided by V2 at V1 is equal to 0, and Y22 is equal to I2 divided by I2 divided by V2 at V1 is equal to 0. Now we can name each of these. Y12 is transfer admittance with input port short circuited, or it is called short circuit reverse transfer admittance. And Y22 is called short circuit driving point admittance with input port short circuited or short circuit output admittance. It will be easier for you to study all the second names: short circuit reverse transfer admittance, short circuit output admittance. Okay, and all these admittance parameters are measured with the input or output port short circuited, and this is the reason why it is called short circuit admittance parameter. Now we are going to draw the equivalent circuit of the Y-parameter two-port network. By seeing this equation, we know that in the left side we have current. That is, these two are two currents. Okay, these all are currents. This is a sum of current. V into admittance means current. So we can draw the equivalent circuit as, here we have I1 is equal to Y11 into V1 plus, this is a dependent current source, that is here Y12 into V2, that is this V2 is the voltage at this side. This dependent current source depends on the voltage at the output port. That is why it becomes a dependent source. It is a sum of two currents. Okay. Here in the output side, I2 is the sum of V2 into Y22 plus the dependent source current. Here V1 is dependent on the input voltage. Next, condition for reciprocity. Reciprocity states that the voltage to current ratio in this case is same as that in this case. Okay. The difference between these two cases is that here the voltage is given at the input and the current or the response is taken at the output port. Here the voltage is given at port 2 and the response is taken at port 1. So in these two cases, the voltage to current ratio is equal, means the network is reciprocal. So we are going to prove that, or we are going to find the condition for reciprocity in terms of Y parameter. So let's take this circuit first. Here V1 is equal to Vs, V2 is equal to 0. I1 is equal to I1 itself. I2 is equal to I2 minus I2 dash. In this circuit, let's see. V2 is equal to Vs. V1 is equal to 0 because it's short circuited. I1 is equal to minus I1 dash, and I2 is equal to I2 itself. What we have to verify is the ratio of I2 dash by Vs is equal to I1 dash by Vs. I2 dash by Vs from this case and I1 dash by Vs from this case. These are the basic Y-parameter equations. So, to verify this case, we can put these values in this equation. First of all, let us take the first equation. I1 is I1 itself. I1 is equal to Y11 V1. V1 is Vs plus Y12 V2. V2 is 0. So this term will go to 0. And I2 is equal to Y21 V1 is Vs plus Y22 into 0. So here we have two equations. What I2 is minus I2 dash. Minus I2 dash is equal to Y21 into Vs. So what we need is Y2 dash by Vs. Okay. So from this equation we get Y2 dash minus I2 dash is equal to Y21 into Vs, that is minus I2 dash by Vs is equal to Y21. Now let's put these values in these two equations. So let's write I1 is minus I1 dash is equal to Y11 into V1. V1 is 0 plus Y12 into V2. V2 is Vs. Next, I2 is I2 itself. I2 is equal to Y21 into V1, which is 0, plus Y22 into V2, which is Vs. So, from this, we can get an equation in I1 dash and Vs. That is I1 dash by Vs is equal to Y12 minus. Okay. So we need the condition for reciprocity is that this is equal to this. That means for in terms of Y parameter, we can say that Y21 is equal to Y12. If the Y parameters are given and if Y21 is equal to Y12, then we can say that the two-port network is reciprocal. Next, condition for symmetry. Condition for symmetry is that the voltage to current ratio at one port be the same as the voltage to current ratio at the other port, with one of ports short circuited. So here we can use the same circuit as that we used for reciprocity. These are the Y-parameter equations. We have to consider case 1. Output port is short circuited, that is V2 is equal to 0. When V2 is equal to 0, we will have I1 and V1 at the same port. VI ratio at one port. Okay. When V2 is equal to 0, we have in the second equation I2 and V1. But we need the voltage ratio at one particular port is same as the voltage ratio at the other port. So when output port is short circuited, that means when V2 is equal to 0, V1 by I1 ratio we have to find. V1 by I1 is equal to Y11. V1 is Vs. Vs by I1 is equal to Y11. Now we can consider the case 2 when the input port is short circuited. That is when V1 is equal to 0. When V1 is equal to 0, we have Y22 is equal to V2 by I2. Y22 is equal to V2 by I2, and here V2 is Vs. Vs by I2. Here when Y1 is 0, also we have Y21 is equal to I1 by V2, but we don't consider this because these are in the different ports. Here we need the voltage ratio at one particular port be same as the other port. So the condition is Y11 is equal to Y22. Thank you.